Good morning everyone. I am Dr. Shanmugh Kuchpal, Academic Coordinator from Suresh Angadi Education Foundation, Angadi College of Commerce and Science, Sangwa Road, Belgaum. Today we discuss another topic. It is called complex number. So I hope you already have studied the complex number. See, once again we will go through basic definitions and then we will go to a multiple choice questions. So first we will define what is meant by a complex number. A number of the form x plus iy, where x and y belonging to the set of a real number I equal to root of a minus 1 is called as a complex number. So generally we call it as a I, but its name is iota here. It is called as a iota. So generally we call it as a I only. So in this video I am going to use I. So any number in the form of a x plus iy is called as a complex number. Here x is called as a real part of a complex number, iy we call it as a imaginary part of a complex number. Then we will define next definition, conjugate complex number. Conjugate of a complex number. If there exists a complex number z equal to a plus ib, z equal to a plus ib, then conjugate it is denoted by z conjugate equal to plus I, we have to make it as a minus, that is a minus ib is a conjugate of a complex number. Suppose z equal to x minus iy, then its conjugate is x plus iy. Okay, like that conjugate of a complex number is defined. Next we will define modulus of a complex number. So z equal to a plus ib is a complex number. Then modulus of a complex number is denoted by mod z equal to under the square root of real part square. Real part is a, it's a square, a square, and imaginary part, that is I we have to leave b, it's a square, b square. So mod z equal to under the square root of a square plus b square, we call it as modulus of a complex number. Then we will go to a example. So first example I will read out. If 1 plus I divided by 1 minus I equal to 1, then the least integral value of m is, that we have to calculate. In our PUC first year we have studied this type of example here. So it was a lengthy procedure. So simple technique we are going to use it. So here I take a given expression 1 plus I divided by 1 minus I. Okay, now denominator conjugate, we have to multiply and divide it. So it is multiplied by 1 plus I divided by 1 plus I. 1 plus I. Okay, like this. So numerator it is in the form of x plus y into x plus y. It is x plus y whole square. So we have to expand it. A square, 1 square is 1, b square, I square it is minus 1 plus 2ab. So we get a 2i. And whole divided by, it is of the form a minus b into a plus b. See, suitable formula is a square minus b square. So 1 square is 1, next minus as it is I square, it is a minus 1, minus into minus we get a plus 1. So in the next step, plus 1 minus 1 get cancels, we get 2i whole divided by 1 plus 1, it is a 2, then 2 going to cancel. So left hand side it is a expression, it is a I, solution is I raised to m, and RHS is equal to 1 here. Yes. So next, what value of I we are going to get a 1. So we know I equal to root of a minus 1. If you square it both sides, we get a I square equal to minus 1. Then I cube is it is a I square into I square is minus 1, minus 1 into I, it is a minus I. And I raised to 4 is, it is I square into I square, minus 1 into minus 1 plus 1, we get it. So this value I am going to use here. So it is I raised to m as it is, and 1 we take it as I raised to 4. Now bases are same, powers we can equate, so we get the value of m equal to 4. Therefore B is a right answer. B is a right answer. Now we'll move to a second example. The value of I raised to 592 plus I raised to 590, like that, so on it is. So whole expression minus 1 equal to, we have to find a solution for this. See, looking at this example, it looks very complicated. So solution technique is very simple. So here in this expression, least I value is I raised to 584. So I am going to take I raised to 584 as a common. So if you take that common, we get I raised to 8 plus I raised to 6, next I raised to 4 plus I square plus 1 whole divided by, here least value is, it is I raised to 574. If we take it that, so we get I raised to 8 plus I raised to 6 plus I raised to 4 plus I square plus 1. This expression minus 1 I am going to write here, and we can clearly see here that 1 plus I square plus I raised to 4 plus I raised to 6 plus I raised to 8, it is present in a numerator as well as a denominator. We cancel it. So after cancelling, we get I raised to 584 divided by I raised to 574. Use a laws of indices, that is A raised to m divided by A raised to n, it is A raised to m minus n. So we get I raised to 584 minus 574, we are going to get answer as a 10, and this minus 1 we write as it is. Then see, all of you know, see how to solve this I raised to 10. So we take I raised to a 2 every time, then 2 5s are 10, 2 5s are 10 minus 1. So we know, all of you, yes, I square is minus 1 raised to 5 minus 1. Minus 1 raised to odd number, it is a minus 1. Minus 1 raised to even number, it is a plus 1. So here it is a minus 1 minus 1. That is, answer is minus 2. Therefore option B is a right answer. Next we'll move to a third example. Now in this example, it is given that 1 plus I square plus I raised to 4 plus I raised to 6 plus so on plus I raised to 2n is equal to, okay. So for that we need to simplify, then guess the correct answer. So options are positive, negative, 0 cannot be determined. Okay. So now 1 we write as it is, I square it is a minus 1, I raised to 4 it is a I square square, minus 1 square is a plus 1. Then I raised to 6 it is I square raised to 3. Yes, I square raised to 3 it is a minus 1 raised to 3, so it is a negative number. Then so on. So we have a last part I raised to 2n, that is here it is n, we don't know whether n is a positive number, negative number, we don't know that. So we write this as I square, this can be written as I raised to 2 raised to n here, like this. Here it is plus 1 minus 1 plus 1 minus 1, they are going to get cancelled. So finally we get I square as a minus 1 and raised to n. I told you we don't know the value of a n, whether it is a positive or negative, it is not known to us. Therefore correct option is cannot be determined. Okay, right, we'll move to our next example. So it is I square plus I raised to 4 plus I raised to 6 plus up to 2n plus 1 terms, 2n plus 1 terms. So it is I square, we write it as a minus 1. Then I raised to 4, we know it is a plus 1. I raised to 6, so I told you it is a I square raised to 3, I square is minus 1, minus 1 raised to an odd number here, so we get a minus 1. So next we get a plus 1. So here it is said that up to 2n plus 1 terms, so it is minus 1, yes, or else we write I raised to 2n minus 1, like this. Then plus 1 minus 1, minus 1 plus 1 get cancels. Then we get I square raised to, it is a 2n minus 1 means it is a odd number here. So odd number means we get answer as a, yes, we will get answer as a minus 1. Therefore which is the correct option? Yes, D is a right answer. Okay, D is a right answer. Next we'll move to a fifth example. If I equal to root of a minus 1, then 1 plus I square plus I cube minus I raised to 6 plus I raised to 8 is equal to. So 1 we write as it is, I square we write it as a minus 1, I cube it is a I square into I, so I square is minus 1, so we get a minus I. So if you are having a difficulty in writing, see I will split like this, I square into I minus I raised to 6, it is a I square raised to 3, and I raised to 8 you can write I square raised to 4 here, like this. So plus 1 minus 1 get cancels, so we get I square is minus 1, minus 1 into I minus I it is, and I square is minus 1, this is outside minus, I square is minus 1, minus 1 raised to 3 odd number, so it is minus 1, minus into minus plus 1 we get it. Next further I square is minus 1, minus 1 raised to even number, it is a plus 1. So further we can simplify this, 1 plus 1 it is a 2 and minus I as it is. Okay, therefore 2 minus I is the answer, therefore correct option is A. Then we'll move to our next example. It is given that I equal to root of a minus 1, otherwise I square equal to minus 1. Then the value of summation n takes the value from 1 to 200 I raised to n is. So this can be written as, so it is, I take n equal to 1, I expand first, so I take n equal to 1. So taking n equal to 1 means, so we get I raised to 1. Next we take n equal to 2, we get I square. So next number, so we get 3, like that, so on. So last term we are going to get it as I raised to 200, like this we get it. So we observe that which is geometric progression, So we write a formula for this geometric formula. Sn formula is Sn equal to, it is a into 1 minus r raised to n divided by 1 minus r. So this is equal to a is, it is a first term, that is a I. Yes. So next 1 as it is, minus r common ratio, it is second term divided by first term, I square divided by I, we get a I. Yes. So raised to n, it is n is up to a 200 terms here, whole divided by, it is 1 minus r, so it is 1 minus I. So it is 1 minus I. Further, so I write it as, this is a I, so 1 minus I raised to 200 can be written as, it is I square. Yes, it is a I square raised to 100, right? I raised to 200 can be written as I square raised to 100. So I square is minus 1 raised to 100, so we get a plus 1, plus into minus, so 1 minus 1 whole divided by, it is 1 minus I. So we observe that plus 1 minus 1 going to cancel, so 0 divided by 1 minus I, so we get an answer as a 0. Therefore option C is a right option. So we'll move to our next example. The value of the summation n takes the value from 1 to 13 with the expression I raised to n plus I raised to n plus 1, where I equal to under the square root of a minus 1 is equal to. Okay, so first we'll expand this. So I take the value of n equal to 1. First I expand first term and then I am going to expand the second term. So I take n equal to 1, I get I, next 2 I square, so on, like that. So we get last term I raised to 13. On the other hand, second term I expand, so I take n equal to 1, we get a I square, and then I cube, then like that. So it is I raised to n plus 1, we get I raised to 14. So this is a first term expansion, this will be a second term expansion. Now sum of our terms formula we have to use it, that is A is I, in a first expansion A is I, it is 1 minus R is I raised to n is 13 whole divided by 1 minus I, 1 minus I, plus as it is. So here it is, A is I square 1 minus I raised to, it is a, we are going to get 14 whole divided by, it is 1 minus I, 1 minus I. Okay, if you simplify this, so we get I 1 minus I raised to 13 can be written as I raised to 12 and I raised to 1 here, so that will become a I divided by 1 minus I. Okay, and I square as it is, I square as it is, we get 1 minus I, it is I raised to 2 raised to 7, it is a, so we are going to get I here, right, divided by 1 minus I. So here 1 minus I, 1 minus I, from numerator and denominator get cancels, here also get cancels, so we left with I plus I square. So I write I as it is, I square is minus 1, so plus into minus, minus minus 1, so correct answer is I minus 1, therefore option B is a right answer. Next we'll move to a example number 8. So question is the least positive integer n which will reduce I minus 1 raised to n, yes, raised to n, I minus 1 divided by I plus 1 raised to n to a real number is. Okay, so for that we have to take I minus 1 divided by I plus 1 and we have to multiply and divide by its conjugate here. So we get, yes, it is a I minus 1 and I minus 1. So numerator, it is of the form a minus b into a minus b whole square, a square minus 1 b square, that is 1 square is 1, minus 2ab minus 2i whole divided by denominator is of the form a plus b into a minus b, a square minus b square, I square is minus 1, yes, and this is a minus 1 like this. Okay, so in the next step minus 1 plus 1 get cancels, so we get, yes, minus 2i divided by minus 2, minus 2 get cancels, we get the I. So what we observe, it is not only I raised to the power n, so I take it as a n. So if we take n equal to 1, it will become I raised to 1, we get a complex number as a I. If we take n equal to 2, so n equal to 2, I square it is, we get I square is minus 1, which is a real number, therefore the suitable value of n is 2, therefore option, yes, option A is right answer here, option A is a right answer. Next, the value of I 1 plus I raised to 8 plus 1 minus I raised to 8 is. So for this, see, we have to write this as, one simple technique is there, 1 plus I take a square of this and it is a 8 means 2 4s are 8, like this we can write it. And another expression we can write this as 1 minus I square I take raised to 4 it is, right. So in the next step we will expand this a plus b whole square, a square, and b square is I square is a minus 1 plus 2ab, it is a 2I raised to 4. So simple mathematics I am going to use here. Similarly, next it is a minus 2 whole square, a square minus b square, yes, plus b square is a minus 1, yes, it is a minus 1, minus 1, minus 2ab minus 2I raised to 4 it is. So what we observe here, plus 1 minus 1 get cancels, here also plus 1 minus 1 going to cancel, so 2 raised to 4 I write, and then I raised to 4, I raised to 4. So similarly here, plus I write, minus raised to 4 plus 2 raised to 4, then I raised to 4. Yes, in the next step I take 2 raised to 4, I raised to 4, yes, this can be written as 2 raised to 4, I raised to 4 can be written as I square into I square, it is going to be plus 1, and here it is 2 raised to 4 here. So 2 raised to 4 repeated 2 times, it is a 2 times 2 raised to 4 here, so we get 2 raised to 5. Yes, 2 raised to 5 is 32, it is a 32, therefore correct option is C here. So remember, we should not use a binomial theorem for this. Yes, so if you use it, it is a very lengthy procedure here. So this is very shortcut trick for you. So that is 1 plus I raised to 8 is written as raised to square raised to 4. Okay, and see, you have to solve such type of a example, and a plus b whole square, directly we have to write a square plus b square is minus 1 plus 2ab, like this. Here also we have to expand it, and both the cases plus 1 minus 1 get cancels, so remove it, that I raised to 4 it is a plus 1, and then 2 raised to 4 repeated 2 times, 2 into 2 raised to 4, and so using the laws of indices, a raised to m into a raised to n, a raised to m plus n, so 2 raised to 5, 2 raised to 5 is 32, so option C is a right answer. Like this you have to use a simple trick. Okay, so similar type of example is there. Yes, I hope, see, similar type of example I have taken for your better understanding here. 1 plus I raised to 10, you can guess this how we can write it. So one hint is, don't use a binomial theorem, because binomial theorem, using that we will get an answer, but we have to use a shortcut trick. Within a 1 minute you have to solve such type of example. So I take this as 1 plus I raised to, yes, you can guess this, raised to 2, and 2 5s are 10 here. Yes, so further, yes, so we know this, a plus b whole square, a square 1 plus b square is minus 1, and 2ab it is a 2I, right, raised to 5, then plus 1 minus 1 going to cancel, so we get 2 raised to 5, last example we have solved, it is 32, I raised to 5, see, very simple, if you get an odd number like this, I raised to 5, this can be written as I raised to 4 into I raised to 4 is, it is plus 1, right, and into I it is, so we get the answer as a I, so 32I is a right answer, therefore option A is right answer. So therefore I have taken a such type of a example. Every time try to represent square in terms of another digit, so that you should get the same number. 2 5s are 10 in this example. Dear friends, we'll move to a next example. It is x equal to 3 plus I, then x cube minus 3x square minus 8x plus 15 is equal to. Okay, so what I will write is from this first expression I write a solution for I, that is x minus 3 equal to I. It is x minus 3 equal to I. On the other hand, I square this, so squaring, okay, so we get a square, yes. Next minus 2ab, so that is minus 3 into 2 into x, 6x plus b square, right? So it is 9, and here it is a I square is minus 1 here, okay. If I transport a minus 1 to a LHS, we get a x square minus 6x minus 1 this side, it is a 10 equal to 0. 10 equal to 0. Then this x cube minus 3x square minus 8x plus 15 can be written as x into x square minus 6x plus 10 plus 3 times it is a x square minus 6x plus 10, close this, minus 50, right? So but x square minus 6x plus 10 is 0, so this part will become a 0 as well as this part will become a 0, so we are left with, it is minus 15 here, minus 15. Therefore option D is a right answer. Option D is a right answer, right? So we'll move to our next example. The smallest positive integer n for which 1 plus I raised to 2n equal to 1 minus I raised to 2n is, see, smallest positive integer we have to take it. So for that I take this expression and then this term I transport it in a LHS. We have to transport it in a LHS, so we get this expression as 1 plus I. So I am not going to solve stepwise, you have to use some basic tool. So 1 minus I, so now both side powers are same, so here only I write it as raised to 2n, and RHS nothing is there means there will be 1 here. So like this, instead of writing 2 steps, in 1 step I have written, okay. So you need a practice for this, okay. So every example here you have to solve it, okay, right? So I take, see, p by q complex number, 1 plus I divided by 1 minus I, you know what is the next step. It is very simple, we have to rationalize the denominator. So it is, I am not taking now 2n, yes, so it is 1 plus I divided by 1 minus I, and its conjugate is 1 plus I divided by 1 plus I it is. So numerator it is in the form of a plus b into a plus b whole square. See, you know this, yes, many times we have solved, it is a 2i, right? So I will explain you once again this, a square 1, b square I square is a minus 1, plus 1 minus 1 get cancels, 2ab, 2i, okay. Then it is of the form a minus b into a plus b, a square minus b square, 1 minus I square is minus 1, so we get it as a 2, and here I use a power as a 2n. Now 2 get cancels, so RHS part it is a 1, so I what value is 1, I raised to what value we get a 1. See, so many times we have solved. See, I is root of a minus 1, I square is, it is a minus 1, I cube is minus I raised to 4 equal to plus 1. So what I do, it is a I raised to, I write 2n, and 1 we take it as I raised to 4. Now bases are same, powers we can equate. So 2n equal to 4, 2n equal to 4, therefore the value of n equal to 2. Therefore option B is a right answer. So we move to a next example, that is 1 minus I divided by 1 plus I raised to 100 is equal to A plus IB. Then see, we have to calculate A and B value here, and see among this A, B, C, D option we are going to get an answer. So it is not a complicated. Raised to 100 means we think of using a binomial theorem. So with a simple trick I'll solve this example. Very simple it is. So 1 minus I am not taking a power right now, and I am not taking a RHS also. So I simplify P by Q complex number. 1 minus I divided by 1 plus I take it. So next it's a conjugate, I multiply 1 minus I divided by 1 minus I and raised to 100, it is raised to 100. So next it is of the form A minus B into A minus B. It is A minus B whole square. So it is a square plus B square, that we get a minus 1 divided by, minus 2AB minus 2I whole divided by, it is A plus B into A minus B, A square minus B square, 1 plus 1 we get a 2. Yes, now 1 get cancels, right? Next 2 are to also get cancels, so we get minus I raised to 100 here, minus I raised to 100. So further RHS part is A plus IB. Okay, so minus I, this can be written as minus raised to 100. It is a minus raised to a even number, so we get I raised to 100. I raised to 100 can be written as, you know this, I square. Yes, we have to start from a square. 2 raised to 50 here. 2 into 50, 100 we get. I square is minus 1 raised to 50, right? So it is a plus 1, and the RHS part is A plus IB. A plus IB. So this also we have to write in a complex form. So very simple. Only real part, I write a real part. Imaginary part, if it is a absent, I times 0 we have to write. This is equal to A plus IB here. Now we observe that, yes, real part we can equate here. The value of A equal to 1. Imaginary part will equate. So B equal to 0. So we get a solution as A equal to 1, B equal to 0. That is correct option is B. So I hope you understood this example. So like this, without using a binomial theorem, using this a simple trick, we have to solve an example. So we'll move to a next example. So Z1 is a complex number. This is another way of representing a complex number. So Z is a complex number, Z1 is a first complex number. So I write this as Z1 equal to, first coordinate is a real part, second coordinate is a imaginary part. 4 plus I5 or 5I. Z2 equal to, it is a real part is minus 3, imaginary part is, it is a I times 2. Then Z1 divided by Z2 is equal to, yes, for that I take Z1 divided by Z2, Z1 divided by Z2, then we'll take, substitute the values, 4 plus 5I divided by minus 3 plus 2I. Then denominator, it is a complex number, so we have to take a conjugate of this, minus 3 minus 2I, then minus 3 minus 2I. right? So further we have to simplify. Here it is not of the any of the standard form here, so a plus b into c plus d. If we simplify this, we get minus 12, 4 3s are 12, minus 12, similarly minus 8i minus 15i plus 10 here. What I have done, 4 is multiplied with these two elements, 5i is multiplied with these two elements. Denominator it is of the form, yes, a plus b into a minus b here. So a square minus b square, we get 9 minus 2i whole square here. Okay, so if we simplify, so we get minus 2, yes, minus 12 plus 10, minus 2 divided by I square is minus 1, so 2 square is 4, right? Minus into minus plus, 9 plus 4, 13. Then it is a minus 8i minus 15i, it is minus 23, denominator is a 13, is a complex number I. So first coordinate, it is a minus 2 13, minus 2 13, yes. Second coordinate is minus 23 divided by 13, yes. So here very confusing here, which is the correct option? Look at here, along with the sign, both are negative here, so C is a right answer. Okay, dear friends, today we have solved these examples, 14 examples we have completed. Remaining examples we continue in a next session. If you are having any queries in a WhatsApp group, there is a numbers are there, admin, you can send a message to admin here, like that you can clarify your doubt. Okay, once again good afternoon everyone, thank you.